want to show an error in the manual I got on the VersaTuner 2 from 2012. This is manual version, says 3A. Anyways, when I turn the inductor here fully clockwise, it has the highest reading on here on the setting, and that is with the contact all the way down here, and the bottom end of this is grounded. So when this is all the way to the bottom, this is tied connecting to the center of the T here, that has the minimum inductance. So over here, this should read the roller inductor in the MFJ 969 has the minimum inductance in the fully clockwise position. So this paragraph is kind of boogered up on, at least on my manual, and I want to point this out because it was kind of driving me nuts. So this should read, it has a minimum inductance fully clockwise position, highest number, okay. And it has the maximum inductance in the counterclockwise rotation, or the lowest number. So I want to point this out because there may be a bunch of manuals out there that are still wrong. On here you've got the center of the two caps here. This is the wire goes over to here. One end is grounded. The ground connects up to the contact, and so right now I'm just using a little bit of coil. It goes from here to the contacts. I'm using 2 loops here, so that's got a very small inductance, which is used for a higher frequency. The bottom end of the coil here is grounded, which would go to the ground of one of the PL259s. Here I've got just a little bit to the center of the caps, like over on here. I've got just a little bit being used, which means this contact's way up at the top. And so on here I've got a little bit of coil used, and I've got a high number, and so this should read a minimum inductance in the fully clockwise position. And of course here, well, this is a tuning chart. When you have a low frequency, you got the inductor generally set to be a low number, which is more inductance, and then if the number is high on the counter, it's a low inductance. So all this is correct. It's just this paragraph's a little bit screwed up. It's a pretty good tuner. It just takes a while to kind of move. Sometimes I like to use tuners where you go through and you adjust the tap real quick. This is pretty much, you've got a much more range because you don't have discrete spots, but it just takes a while to crank this thing through. There's of course the 2 caps, and of course on here, like a lot of them, when you've got a high number on here for transmitter antenna, you've got, it reads backwards, of course, like a lot of them do. When you've got a lot of capacitor engaged, it's low, and generally you want to have this set so that you've got the most capacitor engaged, so you're using the least amount of coil, so you get the highest efficiency in there. Of course, this is the balun. This is the battery, goes in here, 9 volt. They got a little drawer under here, you can take it out. That's been in there for 5 years, and I just replaced it for good measure because I didn't want to have, you know, typically I forget about stuff and then it goes bad. I usually put the date on here. So I took the battery out here. I'm going to put it in something else that'll be used up real quick. The battery draws, it lasts a long time. There's a little balun for feed lines, and I'd like to mark up stuff how it works, and here's where you add the jumper. There's the roller inductor. This is a little shorting switch that knocks out part of the coil when it gets all the way to the end, I believe. So when it's all the way down over here, you want to traverse this thing, you're going to spend a bunch of time. So if you got some fixed antennas, you want to make a cheat sheet, of course, to show what you're doing, because you're going to, if you want to sit there and quickly turn this and optimize something, you're going to go crazy, because you're going to sit here and have to go through and turn this thing over and over and over again. So when I first got this thing, I was like, holy smokes, this is just taking a lot of time. And I'm turning this thing like mad over here. So if I go all the way to the end here, that's the max inductance. This whole coil's being used. And it's got 0. So when you got the whole coil used, you're using generally this at a lower frequency. And to get that, again on mine, I don't know if they've changed the design in this thing. I'm turning this counterclockwise. Counterclockwise to get the most inductance. So maximum inductance in the, it says counterclockwise rotation, lowest number. And I guess I said that backwards. This is counterclockwise. So turning this counterclockwise, I've hit 0, and it's got the biggest inductance. That's about it. It's a pretty good inductor device. I like to mark all my stuff up with a bunch of notes because I end up forgetting it. But I've actually taken this thing apart a couple times and put some cheat sheet notes on it, because it was driving me nuts about what was going on, because I read this paragraph on here and kind of like started using that as my frame of reference, and then I started to adjust it, and it was kind of like going nuts trying to figure out what was going on. There's the forward and reflected meters. You've got the tuned and non-tuned section, and then you've got the peak circuit there, and the power circuit, 30 watts and 300 watts. There's the clock chiming. There's the dummy load that's in used here. In the back over here, you've got coax 1, 2 transmitter, balance line. This is the power, I believe, for the light. I think it also will bypass for the battery. It's got some diodes in there. I think if you only use the battery, the meter only works to 250 watts instead of 300 or some goofy thing like that. But the battery's a good design, because I'm normally not using that much power with this thing, just a 100 watt barefoot rig. There's the circuit board, of course. I think the power meter in mine is fair. It's close. It's not as good as a bird. Again, there's the inductor. Then the dummy load on there. They got a little chart over here. Haven't had enough coffee here yet. Number of watts, this is the D rating versus minutes. 300 watts for 30 seconds, 100 watts for 90 seconds. Of course, the schematic over here has got it classical T, where you've got 2 variable capacitors and then the inductor. And then this is the SWR circuit, where you've got the sense coil, the 2 diodes, and then you've got the 2 meters reflected in power. The battery comes in over here, 9 volts through a diode to the 2N3904, or the 12 volts. So I think if you hook the 12 volts into the diode, the battery is, you can leave the battery in there. You get a little bit higher rail voltage with the 12 here versus the 9. And that just supplies, I think, power to the meter circuit here. Got the forward and reflected. So they got two swings on there. forward and reflected. One goes to this side of the coil over here, one goes to the other side. And there's a little tuning cap they've got in there, I guess to, maybe that's for the SWR circuit. This has got a date here of 1997. Of course, here's the ballon with the wire that you add when you want to use it. So the ballon device here is just sitting by itself, not hooked up like a lot of them, until you put a jumper across here. So normally, of course, this is not in use. You just have the wire connection. Now, one of these devices, when you say it's 300 watts, what happens is that one crude way to assume an antenna tuner works, it's almost like a transmission, a gear ratio, in the sense that if you put a 300 ohm load in here, and you put 300 ohms in, you can put a lot of power through one of these. If you have some weird load here that's just a couple ohms output, or real high or low resistance, the transformation of where the caps and coils has to be, he has to bump the voltage way up or the current way up to go ahead and make the transformation. So you're going to run in a situation the coil is going to get hot because you got a lot of current going through it, or you're going to get the situation you're bumping the voltage way up and you're going to have arcing in here. So like a transmission in a car, if you geared something way down, you want to put a huge amount of torque, you're going to shear off some bolts or some gears or something. Or if you want to go ahead and have high RPM, you're going to go ahead and tear up something because the RPM's way too high. And it's the same thing on here. You take an antenna tuner, and technically what happens is that if you want to go ahead and look what the max power is, you've got to look what the SWR is. If you had try to match something through here that was, instead of, let's say, a 5 ohm load, then you're making a transformation of 10. You may or may not be able to put 300 watts in because you're going to have to bump the voltage up 5 to or 10 to 1. And so you're going to get arcing going on here. Or if you want to, if you want to have 500 ohms out of this thing on the connector, you're going to have to bump the voltage way up. If you had 5 ohms, then you have a lot of current. You're going to get a situation where this thing's going to tend to want to heat up a lot, and you're going to have melting going on. So in a bigger tuner, you're going to have bigger diameter wire because all the current's on the edge of the coil because of the skin effect generally at high frequencies. Or you can have arcing here on the cap. Now this is a good little device. First got this again using the roller inductor, kind of like, I thought, wow, this is really cool. I can go through and you know, tune anything I want. And then I kind of got a little bit annoyed with myself, whatever, that, you know, it takes a long time to turn this darn thing. And so if you got an unknown antenna, it's a little bit frustrating because you can't just, one, that you can sit there and click through the discrete steps of, with taps, bang, 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 across here is easier to kind of home in what you want to do. So the key to using one of these, you really want to have a cheat sheet once you get what's going on. There is some crosstalk between here if you've got something coax 1 and 2. If you had, let's say, coax, you're on the dummy load, you're going to probably get a little bit of power out of one of the other connectors, you know, way, way, way down, but it's not completely isolated. So if you want to, you know, tune up and you doing a bunch of goofing around off band, you may want to disconnect your antenna and just use the dummy load and don't have it hooked up because you might be transmitting out. Let's say you want to just test an amplifier at, you know, 6 megahertz off the ham band, and you're just curious what's going on. I would disconnect this from your antenna because you might be illegally transmitting out. And that's with a lot of these tuners. You've got not complete isolation in the sense that you're going to get some maybe 20, 30, 40 dB down out of one of the connectors because of the you know, everything's so close, proximity there, what's going on. This was bought brand new at I think at the Jackson Ham Fest about in 2012. I'm not sure if I got this from MFJ or another dealer. They usually visit the Jackson Ham Fest once a year, MFJ, because it's just down the road. They got their truck and everything. This is kind of just an impromptu video, so I apologize. It's probably kind of hokey. And there's the classical T, 2 caps. You can tune just about anything with one of these. You got the input, the cap, inductor, and the output cap. And normally you want to use the largest capacitance you can have on here, and then so you're not using as much as the inductor, so you get less loss. So if you've got more than one tap position, you really want to use one where you've got these close to the zeros here. One way to kind of think about that is that you got less loss generally when you're way down on here, where you've got the most cap engaged. There's a lot of these T's. This is a Heath kit, one I built years ago. I digress here. The 9. And it was first came out, it was rated as a 50 watt unit, and then here's one here, it says 100 watts. So I'm not sure what the story is on that. That was HFT9. MFJ uses the same inductor, the dummy load here, for a lot of different things. And sometimes when you buy one of these things, you got to make sure everything works, in the sense that, you know, there's quality issues. It can get screwed up in shipping. If you buy one used, sometimes somebody will fry the connectors, you know, on the contacts here because they did something stupid. You go ahead and have a big transformation here where you've got, of course, high voltage. What will happen, it'll actually arc here. So if you want to look at a tuner for a linear that was, say, 2,000 watts or something, physically the plate spacing will be thicker, more. And that's just so you can run at a higher voltage. I'm just eyeballing this. It looks like it's about a millimeter gap on each one of these. So if you took one of these for, let's say, 600 watts, 1,000 watts, the capacitor is going to be physically longer generally, got a bigger spacing between them, between each little tine. And then the coil here will physically have generally bigger wires, bigger coils, and they will be bigger diameter, and sometimes a bigger spacing on there. When these get old, a lot of times these get kind of corroded and stuff. Again, the irritating thing on this is that it takes a long time to traverse from one end to another. And so I actually prefer the tap version for an unknown antenna. If I just want to do listening and rig up an antenna, I much rather use a tap antenna. Because then I can go through and move this. And when I first got this thing, again, I was using this statement over here as the Bible. I said, okay, I'll go through and, you know, use this statement here. And I was actually using the wrong settings, in the sense I would go ahead and try to find an optimum setting, you know, and I was at the wrong end of the coil. Now I've got another version of one of these, and kind of a nitpick. This one, the location of the little white thing to the setting the knob is fairly decent. I've got another version of one of these, is different model that it's really kind of hokey in the way it's set up, and that it doesn't really line up very well. Again, that's sometimes just a issue how stuff's made. The on-off button here, let's just go look at this real quick. Is that really turning the battery on and off? The battery is always connected to the diode. Where's the on-off button? The on-off button is just grounding the meter here. So when off, on, the meter goes through here, goes through the cap, grounds the meter, goes through this resistor, low or high, and then goes through this emitter to here. So you could have some current maybe flowing through this diode, small amount. Now if there's nothing on this, the base over here, it may or may not be conducting hardly anything. Probably not. Again, there's the on button, grounds the bottoms of the meters. Here's the calibrations, low and high, the 50K pots over here. The peaking has just got a variable cap here. Drops in a cap. 22 microfarads, 100. There's a 47. Now those caps there, if you look at them, got a little pie side there. Those are electrolytics. And on another model I had that was one of these, I had some of these, of course, with bad caps. They're down in there. Those are electrolytics. And of course, sometimes, they've had, all manufacturers have had different things of electrolytics. And electrolytics are kind of hokey in the sense that they, their tolerance is all over the place, and they tend to go bad with time. And in this type of circuit, they're rarely used. So if the peaking is kind of hokey, those could be bad. In the sense here, you got a 220. Let's say we'll look at the Ford, the peak circuit, 100 microfarad, 47 microfarad. Electrolytics on something like this, the value's all over the place, and what it's doing is just charging that cap up. But it could be that those are leaky or doing something kind of weird. So one way on a device like this is actually to pull them out and check them, or just to make sure they're visual, you don't have a bunch of crap on them. I've had another device I had that wasn't MFJ, but you looked at them and they were all just had white goop coming out of the caps right there. Here's the trim pots. I'm going to just put this video all up completely unedited, so bear with me, I'm just kind of rambling here. All looks nice and clean because I bought this new. I had another type of MFJ meter that the darn meter circuit's completely dead. And so I've got to go through and check it out, what's going on there. This is, of course, got two different swings on it. I want to say they changed this, I may be full of it, but I remember one time, one of these versions, I had something else like that they didn't have this cover. Here you can undo the cover to replace the battery, which is kind of neat. Got long leads. That little bow in there is pretty small, so when you start talking about 300 watts, you just wonder if that's really going to be big enough. I'd say it's good for 100. Now, when I digressed a minute ago and talked about my Heath kit here, HFT9, there's an A and a non-A, and I think that one says 50 watt, one says 100, I'm not sure. But those things, when I've gone through and run a weird load, I've had times where I can only put 10 or 20, 30 watts in because of the transformation of the impedance on the thing was such that, I had arcing going on here. And the Heath kit one like that has got taps. There's a little roller contact in there. And that's about it. I'm going to wrap this up, kind of a long, windy video. These are generally fairly decent in the sense that I don't think the meters are all greatly calibrated. They can maybe be pretty good, maybe not. What I ought to do is I ought to go through and measure with an amp meter through here what the load is. See, this is 200 microamps. I'm going to do that here in a second. Okay, I've got the peak button in here, and when I go over here and try to measure the current, doesn't look like I can measure anything here. Maybe my setup's kind of hokey, but this meter, 200 microamps, full scale. Tried a bunch of different scale. I can't get any difference in reading. Now this is with the unit off, nothing hooked up, and I've got gone through all the combinations of the peak and average, and then the on-off. So maybe it doesn't have any draw at all with the button on and no RF in. But maybe on here, I've got to think about this. Maybe that with this setup on here, there's no current flow, even with this on connecting through here, because the base is probably held down or something. Oh well, that's about it. Okay, the Heath kit I was talking about is this little guy here, HFT9A. Basically has inductor, antenna, same T circuit, but this thing is easier to kind of quickly find a setting compared to a roller inductor.